You are given a infinite length rod and it has charge density lambda, and you are asked to find the electric field at point P, which is r distance away from center of rod, and this is perpendicular distance. Okay, so we have to find the electric field by this rod at point P by assuming that this rod is made up of so many point charges which are present from minus infinite to infinite, which are constituting this rod. So electric field of rod, so electric field of rod gonna be electric field of all the points present in that rod from minus infinite to infinite. This is our key concept for solving the problem. And assume a point charge x distance above the rod. This is x and it has length dx and charge dq. It will make electric field dE in this direction. There is also a similar element in downward direction. It has also charge dq and length dx. It will also form electric field dE in this direction. This is theta, this is theta, this is x down, this is x above, and this distance is r, this distance is r. Okay, now both dE equal in magnitudes but have different direction. If this is theta, so this angle and this angle both gonna be theta by simple geometry. And this D has two components. One is upward component, one is rightward component. We say this is vertical component as dE sine theta, and this is horizontal component as dE cos theta. And this dE also have two component, one dE sine theta downward and one dE cos theta rightward. This d sin theta will cancel out this d sin theta and you will remain only with d cos theta. Although this element is making dE electric field in this direction in AP direction, but it has two component, dE sin theta upward, dE sin theta downward and dE cos theta rightward. But dE sin theta will cancel out and you will remain with only dE cos theta. Means the dE has only one effective component, which is dE cos theta. So for finding the electric field of rod, you have to integrate all the dE cos theta from minus infinite to infinite. You can find the value of dE. The value of dE gonna be lambda times charge dq over distance square. If this is x and this is r, so the distance AP gonna be under root of r square plus x square. When you do square, you will cut this bracket, you will left with r square plus x square. This is the value of dE. This is the value of dE. Now put the value of dE, k times dq over x square plus r square cos theta minus infinite to infinite. You have to integrate electric field of rod. And you can also find the value of dq. The value of dq is gonna be lambda times dx. If lambda is the charge on unit length, then the charge on dx length is gonna be lambda times dx. So just put the value of dq, you will get minus infinite to infinite k lambda dx over x square plus r square cos theta. Okay, we have to solve this integration, and this integration is a mixture of algebra and trigonometry, and we will do this integration in trigonometric form. Means I will convert whole algebraic expression in algebra or in trigonometry. So from the triangle you can see very easily that this is x, this is r, and this is under root of x square plus r square, and this is theta, and tan theta is x over r, and you can put x as r tan theta. What I'm doing, I am converting this algebraic expression into trigonometric expression for the simplification of this whole expression, so that I can integrate whole given integration. Okay, so I will put x as tan theta and dx as, I will differentiate with respect to theta, then I will get dx over d theta, and I will get r sec squared theta, and the value of dx I get is r sec squared theta, r sec squared theta into d theta. Okay, this is the value of dx, and this is the value of x. When you do substitution, you have to change the limits also. This is lower limit of uh, x, and this is upper limit of x. So when you put uh, x as infinite and x as minus infinite, you will get two limits. You will get minus pi by 2 and pi by 2. Minus pi by 2 is our lower limit, and this is our upper limit. So the whole expression can be converted into trigonometric expression, which was earlier a combination of algebra and trigo. Now I will put x as a uh, r tan theta, and dx as a r sec square theta. Now I have limits minus pi by 2 pi by 2. I will put k lambda outside the integration because these both are constant, and I had on dx, and I will write on dx as uh, r sec square theta into d theta, and cos theta was there, and I had x square in denominator, and I will write uh, x as x r tan theta, and square was there, plus r square. Now next step, I can take r square common from denominator, and I will have r square outside the bracket, and I will left with 1 plus tan square theta in denominator, and in numerator I have r sec square theta into d theta into cos theta minus pi by 2 to pi by 2. Okay, k lambda was outside there, and it is electric field of rod. Now 1 plus tan square theta is sec square theta, so this will cancel out, and r will also cancel out, and you will left with k lambda, and you can also put r outside the integration because it is also fixed. So put r outside the integration, and you will left with minus pi by 2 cos theta d theta. Okay, as you know, cos theta is an even function, so you can write limits like 0 to 2 pi, 0 to pi by 2 two times, and k lambda upon r as it is, and cos theta as it is. I just applied some basic concept. Let me explain. Cos theta is even function because it is symmetric about x-axis. This is minus pi by 2, and this is pi by 2. When you integrate function, this is cos theta, and this is theta. When you integrate the function from minus pi by 2 pi by 2, so you will get the area under the curve, like this is the result when you integrate the cos theta. But you can also integrate uh, this expression as 0 to 2 pi two times, because it is symmetric about x-axis. By doing 2 times of this area, you can easily get this area. This is the property of even function. So I just wrote minus pi by 2 to pi by 2 as 2 times of 0 to pi by 2 into cos theta, because cos theta is an even function. Now integration of cos theta is sin theta, so we will have k lambda over r, integration is sin theta, and limits were 0 to pi by 2. When you put limit and 2 was also there present. Okay, when you put limit, you will get value 1. Sine pi by 2 is 1, and you will have answer 2 times k times lambda over r is the electric field of rod at a distance r. Electric field of rod at a distance r from center of it. So I hope you understood the topic well. Thank you.